So let's take a look at this and see if any dipoles form from it. What's carbon's number? Good, 2.5. All right. Bromine is 2.8. And then fluorine we know is 4.0. Okay. So check this out. First of all, we know that it doesn't actually look exactly like this, right? This is a two-dimensional representation of a tetrahedral. But you can still use this to get kind of the right answer. And it works pretty okay. All right, so all the bromines are 2.8. If we were just looking at carbon and bromine, the difference between these two is what? 0.3, yeah, exactly. All right, let me change the color so we can keep track of all this. So we have, it would be going down 0.3, going out this way 0.3, and then going that way 0.3, right? To simplify this for this year, if you have things going in opposite directions, they cancel out, okay? Especially if they're the same number. So these two 0.3s are gonna kind of cancel out. We're not gonna worry about them. This one's gonna stay because it's going down, all right? But we're gonna compare it with the fluorine, which is going towards the fluorine. 4 minus 2.5 is gonna give us what? 1.5. So we have overall going up 1.5, but there's 0.3 going in the opposite direction, right? So it's kind of like tug of war where you're going against a small child or something like that, right? So you're pulling and the little guy, like he's pulling a little bit, right? There's a little resistance, but overall you're winning, right? You're pulling it. I don't know why you're doing this to this poor child, but you know, you're just dominating. So what's the difference between those two? 1.2. So you kind of have to look at this overall, what's happening. Overall, it's going up towards that fluorine, right? Because you're, again, pulling against a child in tug of war. So what category does this go into? Non-polar, polar, ionic? All right, polar, yeah, exactly. So you can see that this is going to be polar. All right. Overall, where's the most likely spot that it's going to be negative? Where's that negative dipole going to be? Yeah, exactly, near the fluorine. All right, so near the fluorine. So I'm going to put it up here, slightly negative, up at the top. And then where is it most likely going to be the positive? Yeah, you can just pick the bottom because you kind of want to think of this as you're going to cut the molecule almost like in half and have a negative region and a positive region. So this, the top is going to be negative, and then anything kind of down here is going to be slightly positive compared to that fluorine, compared to that negative region up there. Does that make sense? And if you were going to add another molecule of this to here, maybe like down here, what would be the closest, you know, what would you have kind of closest to this bromine? The fluorine, right? Because it's negatively charged. So as long as you can identify kind of where the dipole-dipole interactions would be, then that's good, all right? Any questions with that one? So this is, we have our dipoles here, all right? We said it was gonna be polar, but we should write it down as well, even though just by writing these, you're saying it's polar, but we're gonna be extra clear on this, all right? So that one would be